Hi everyone, welcome to our class. Today I'm going to discuss Polya's problem solving framework. This is part 1 of my lecture and my discussion will focus on solving number problems. And at the end of this lecture, you are expected to be able to enumerate the Polya's 4-step approach in problem solving, know some strategies in problem solving, identify appropriate strategies in solving number problems, and solve number problems following Polya's 4-step approach in problem solving. I am now going to discuss the typical mathematical problems using the Polya's problem-solving framework. George Polya of Hungary is considered as the father of modern problem-solving. He wrote his most influential book entitled How to Solve It, which is helpful in solving problems that gave birth to his 4-step approach in problem-solving together with different heuristics or strategies. Knowledge of Polya's 4-step approach in problem solving is the first step in becoming a good problem solver. So as a beginner, it is necessary to label and present each of the 4 steps every time you solve a problem. Make it a habit of remembering the 4 steps as you plan and as you work through a problem. So the first step in the problem-solving framework is understanding the problem. So in understanding the problem, you have to get to know the problem by reading it and reread until you have a deeper understanding of the given situation. You have to understand what is asked in the problem and what are the given conditions in the problem. The second step is to devise a plan. So to devise a plan is to choose a strategy or strategies that might be applicable to the problem. So it is important to know that different types of problem has an appropriate strategy to solve it. So some of these strategies are to guess and check, work backwards, solve a simpler problem, find a pattern, make a table, draw a figure, make an organized list, formulate an equation, use a mathematical model, and use a variable. So usually, this use a variable technique is used together with the other strategies. The third step is to carry out the plan. So in carrying out the plan, you have to execute your initial plan. So remember that you may, along the way, revise your plan. The last step is look back. Looking back or making reflection is trying to find out if the answer that you obtained satisfies the conditions given in the problem. I am now going to illustrate the strategies use a variable and formulating or writing an equation in solving number problems. Number problems usually involve finding consecutive numbers. So in finding consecutive numbers, you let the first number be represented by x, the second number be represented by x plus 1, the third number is represented by x plus 2. So notice in here an increase of 1 for each succeeding number. Consecutive, even, or odd numbers. So this can be solved by representing the first number by x, the second number by x plus 2, the third number by x plus 4, and so on. So for consecutive even integers, notice that there is an increase of 2 for each succeeding number. Number problems also involve separating a number, say n, into 2 or 3 parts. What you're going to do is represent the first part by x, and the other will be represented by n minus x. Number problem could also involve finding 2 or 3 numbers. So what you're going to do is you let a variable represent each number. Let us solve this problem. Find two consecutive integers whose product exceeds their sum by 19. We start our solution by understanding the problem. So in the problem, we are asked to find two consecutive integers. It is also given that their product exceeds their sum by 19. So we proceed to the next step, which is to devise a plan. Knowing that this is a number problem and we are asked to find for consecutive integers, we make use of variable and we can write the equation based from the given condition. So if we are going to let the first number be represented by x, then the second number is x plus 1. There is also a mention about their product. So if the first number is x and the second number is x plus 1, then their product is represented by x times x plus 1. There is also a mention about their sum. And so their sum is represented by x plus 1, or we can simplify this as 2x plus 1. The third step is to carry out the plan. So in here, we can now write the equation based from the condition. So it says that the product exceeds their sum by 19. So take note, this is the product and this is the sum. So the product is being compared to the sum, and it says that the product exceeds their sum by 19. Therefore, for this product and sum to be equal, we have to add 19 to the sum. Okay, so simplifying, we now have x squared plus x is equal to 2x plus 20. That is applying the distributive and closure properties. And we can now simplify further as x squared minus x minus 20 is equal to 0. That is applying the subtraction property. We continue our solution. Since we have in here a quadratic equation, we can now solve for x using the quadratic formula or by factoring. So by factoring, we have the quantity x minus 5 times the quantity x plus 4 is equal to 0. And using the 0 property, that if we have 2 or more factors is equal to the product of 2 or more factors is equal to 0, then either factor is equal to 0. So we now set each factor to 0. X plus 4 equal to 0, then we solve for x in each equation using addition property, x is equal to 5, and using subtraction property, x is equal to negative 4. So we are now ready to solve for the consecutive integer. If x is equal to 5, its consecutive integer is represented by x plus 1. So we have 5 plus 1, therefore that's equal to 6. And if x is equal to negative 4, its consecutive integer represented by x plus 1, that would become now negative 4 plus 1, which is equal to negative 3. So we proceed to the next step, which is to look back. To look back is to try to check if the obtained answers satisfy the given condition. So the condition is that the product exceeds their sum by 19. So considering in here, the first set of solutions, we have 5 and 6. So their product, 5 times 6, we check if this exceeds their sum, 5 plus 6 by 19. So we add 19. We now have 30 is equal to 30. We obtained an identity. That means the first set of solution satisfies the condition. And we have the second set of solution, we have negative 4 and negative 3. We try to check again on the product exceeds their sum by 19. So we have negative 4 times negative 3. Is it equal to negative 4 plus negative 3 plus 19? So we obtain in here 12 is equal to negative 7 plus 19, or 12 is equal to 12. That means the second set of solution also satisfy the condition. Therefore, we say that there are two possible sets of answers in the given problem. We have the solutions or the consecutive integers are 5 and 6, or we have negative 4 and negative 3. Let us solve this problem. Separate 65 into two parts so that the square of the smaller is 455 less than the square of the larger part. What are the parts? So we understand the problem. We are asked in here to separate 65 into two parts. And we are given the condition that the square of the smaller part is 455 less than the square of the larger part. Okay, so we devise a plan. So since this is a number problem, it is appropriate to use a variable to represent the unknown and write an equation based from the given condition. So if we are going to let the first part equal to x, then the second part will be 65 minus x. And we have in here the square of the smaller. So take note, in these two numbers, x and 65 minus x, we do not actually know which one is smaller or which one is larger. So you can choose any of these two as your smaller number. So if we take 65 minus x as the smaller number, then its square is written as the quantity 65 minus x raised to 2. And then the square of the bigger number, x, is x squared. The third step is to carry out the plan. To carry out the plan is to construct or write an equation based from the given condition. So the condition is that the square of the smaller part is 455 less than the square of the larger part. So the square of the smaller part is represented by this symbol, and that this is 455 less than the square of the larger part. So we have that is equal to x squared minus 455. So we simplify this equation, square a binomial, we now have 4,225 minus 130x plus x squared is equal to x squared minus 455. So we continue our solutions looking at the derived equation. X squared in here is common, so we can cancel out by subtracting both sides by x squared. And we want also to get rid of this 4,225 at the left side, so we're going to subtract the equation by 4,225. So what is left is negative 130x equal to negative 455 minus 4,225. So we simplify further the right side. That will give us now negative 4,680. So to solve for x, we can divide both sides of the equation by negative 130, giving us the value of x equal to 36. So 36 is one part of the 65, and so the second part is obtained by subtracting 65 minus 36, that is 29. Therefore, the parts of 65 are 36 and 29. We proceed to the next step, which is to look back. In looking back, we have to try to check if the obtained answers, 36 and 29, satisfy all the given conditions. And the first condition is that the whole must be 65. That means the sum of 36 and 29 must be equal to 65. So having obtained this identity, 65 equal to 65, that means the first condition is satisfied. The second condition is that the square of the smaller is 455 less than the square of the larger part. So we now have 29 squared, or the square of 29 is equal to 36, or square of 36 minus 455. So this is 841. We have 1296 minus 455, giving us an identity 841 is equal to 841. So these two conditions were satisfied. We therefore have our final answer is that 65 is separated into two parts, that is 36 and 29. Let us solve this problem. The sum of three numbers is 27. The second is 2 less than twice the first number, and the third number is 5 more than 3 times the first. What are the numbers? We start our solution by first understanding the problem. We are asked in here to find three numbers, and we are given the condition that the sum of the three numbers is 27. It is also given that the second is 2 less than twice the first, and that the third number is 5 more than 3 times the first number. Okay, the second step is to devise a plan. So understanding that this is a number problem, we use a variable or variables to represent the three unknown numbers, and we write the equations based on the given conditions. So let x, y, and z represent the first, second, and the third number respectively. We continue our solution. Step 3 is carrying out the plan. So in this step, we are going to formulate the equations based from the given conditions in the problem. And the first condition is that the sum of the three numbers is 27. So if the three unknown numbers were represented by x, y, and z, then we say x plus y plus z is equal to 27. The second condition states that the second is 2 less than twice the first. And so we have y, this is the second number, is twice the first minus 2. The third condition is the third is 5 more than 3 times the first. So the third number is represented by z, and this is 3 times x plus 5. We now have in here a system of equations. So there are three equations, three unknowns. We can solve simultaneously. So one technique in here is we can substitute y and z in equation 1. So the equation now becomes x plus y, whose value is 2x minus 2, plus z, whose value is 3x plus 5, and that is equal to 27. So we can simplify this equation by removing the grouping symbol. So since this is preceded by positive 1, we can immediately remove the grouping symbols. So further, we simplify the equation by collecting similar terms. So we have x plus 2x plus 3x, that is equal to 6x. Then we can eliminate the negative 2 plus 5 in here by addition property, that will become now 27 minus 3. And simplifying further, we have 27 minus 3 is equal to 24. We solve for x, applying the division property. X is equal to 4. Okay, so we can solve now the value of y by substituting the value of x in equation 2. So we have y is equal to times x, whose value is 4, minus 2. We have 8 minus 2. Y therefore is equal to 6. So similarly, in equation 3, we can solve for z, that is equal to 3 times 4, or 3 times 4 plus 5, that is equal to 17. So we have now solved the values of, we have found the values of the three numbers 4, 6, and 17. So we go to now the last step, which is to look back. So look back is making reflections or checking if the obtained values or answers satisfy the given conditions. So again, we have the first condition is that the sum of the three numbers should be equal to 27. Substituting now values, we have 4 plus 6 plus 17. Try to check if that is equal to 27. So we have 4 plus 6 is 10 plus 17, that's 27, is indeed equal to 27. That means the values of x, y, and z in here satisfy the first condition. The second condition is that the second is 2 less than twice the first. So it's represented by this equation, y is equal to 2x minus 2. So we try to check. Y is 6. This is equal to 2 times 4 minus 2. So we arrive at 6 is equal to 8 minus 2 is 6. And so therefore, this value of x and y satisfy the second condition. The third condition is that z is equal to 3x plus 5. Substituting now values, z is 17, and we try to check if that is equal to 3 times 4 plus 5, and indeed 17 is equal to 17. So, having all the conditions satisfied, we say that the three numbers are 4, 6, and 17. I will end up my discussion in here. I hope you will be able to apply the illustrated strategies in solving problems. Thank you for watching.